Hi, Calc friends. Let me see if this is recording. Okay. Hi, Calc friends. Pre-Calc friends. I welcome you to the flipped classroom, and you'll notice that when we flip our classroom that strange things happen. And it just so happens that when your classroom is flipped, once in a while some weird flipping behavior occurs in your life. Like the other day when I had a flipped classroom, I look over and there's the picture of my grandchildren flipped upside down. So please be careful and cautious as you proceed through this flipped classroom experience, and let me know if you find anything odd that happens. All right, today we're going to start with reviewing what the flipped classroom is. You'll be watching this video, the teaching part of your lesson, and then when you get to class, you'll be doing problems, and that's all. If you do not watch the video, you may be asked to leave the classroom to watch it in some instances, so you'll be somewhat behind if you do not watch it. Definitely conceptually you'll be lacking if you forget to watch the video. So please remember, and today is Flip Classroom number 1. So let's get started. I hope you all are comfy. I'm going to kick off my shoes just right now. And you get comfy, some nice chair and some nice comfy warm clothes and nice drink beside you, a snack, and just enjoy the show. But you do have to take notes to get credit for this video, so please take notes. And here we go. I'm sorry, my head, you'll have the headless teacher returns. Now, my head is out of the video most of the time, but that's just the way it is, so deal. All right, using trig IDs, I want to continue on the trig IDs in just a second, but before we add to our list, I would like to do homework problem number 12 with you. I heard some grumbling about it. So on that green sheet, number 12, I'm going to go over that with you so that you have a good idea of good idea of how these work. And I think it'll help you finish the rest of that assignment on the green paper. See, they give you this, and they give you this. And you have to find the rest of the trig functions, not drawing the triangles, but with trig IDs. So first of all, when I see this business, I immediately do all students take calculus, which tells me what functions are positive and negative in the various quadrants. So this will tell me what quadrant I'm in, and that'll make sure I get the right SIGN sign, plus or minus, in my answers below. So cosecant, which works like sine, because they're in reciprocals of one another. Cosecant's 1 over sine is negative. So sine is negative here and here, because it's positive here and here. It has to be negative here and here. Cosine is below 0, also negative, here and here. So where do those both overlap? Right here. So we know that we're working for cosecant to be negative, since it works like sine, and cosine to be negative. Do you see that we're in quadrant 3? All right. Of course you do. All right, now let's see what we can get quickly. If we know if we know cosecant, we know sine, because they're reciprocals of one another. So when I flip negative 5 over 1, I get negative 1 over 5. And I can go from there and try what would be good to do next. There isn't a real clear choice, is there? So I'm going to work on cotangent. So I'm going to grab a trig ID that has cotangent in it, and 1 plus cotangent squared theta equals cosecant squared. I prefer to work in a function like tangent is sine over cosine or cotangent's cosine over sine, but we don't even have enough information to do that. So since the only thing I know really is cosecant and sine, I've got to grab a trig ID that works with me. So I know this. So that 1 plus cotangent squared theta equals -5 squared. So I have 1 plus cotangent squared theta equals 25. And now I subtract 1 from both sides, and when I get that, I get cotangent squared theta equals 24, and square root it, and I get the square root of 24, which is the square root of 4 times the square root of 6, or 2 square roots of 6 in its best form. So cotangent is, I'll make a list up here because I'll probably erase that, 2 square roots of 6. So right away, you can pause the video if you need to write that down. Right away, if I have cotangent, I can flip it and get tangent. 1 over 2 square roots of 6 rationalized is, let's see if that's in the video. Looks good. Square root of 6 over 2 times 6, which is square root of 6 over 12. So here is cosecant, sine, cotangent, tangent. Alright, so we've only got 4. 2 more. 4 down, 2 to go. So I'll grab a trig ID. I still can't use sine over cosine because I don't have a value for cosine. And I can't use cotangent, same reason. So I have to grab the other Pythagorean ID that has secant in it. And I don't have secant. So I grab this trig ID. And I get 1 plus tangent squared, which I know tangent squared. It's right there, square root of 6 over 12, and that value is squared. We'll mess with that in a minute, equals secant squared. When I square that, I get 6 over 144. Square root of 6 squared is just 6, and 12 squared is 144. And that reduces to 1 over 24, 1/24 plus 24 24ths is 25 24ths equals secant squared, square root both sides, and that gives me the plus or minus business. And did I do that over here? When I took plus or minus somewhere, I erased it. Yeah. I guess that's when I took the plus or minus there. I got this. So this should have been plus or minus, but because it's cotangent, I can look here, it works like tangent. So in that quadrant, where's my cotangent work? Tangent. In this quadrant, cotangent works like tangent, so it's positive. So when you take the square roots of both sides, remember it creates a plus or minus. So somewhere on the board you have to figure out which one to use. So I have square root of 25 over the square root of 24. And the square root of 24 is square root of 4 times square root of 6, or 2 square roots of 6. So now I have to rationalize that. And all this is my secant work. So when I rationalize that, I have to multiply by square root of 6 over square root of 6. Square root of 25 is 5. And square root of 6 times square root of 6 becomes 6 times 2 is 12. But the question is, do I use the plus or the minus? And this is secant. Secant works like its reciprocal, which is cosine. So what is happening to cosine in this quadrant? It is negative. So there we go with that one. So now that we have secant, we can get the reciprocal. So this one is secant theta. So all I have to do is flip that and I can have my cosine, and that'll be it. Cosine of theta equals the flip of that, negative 12 over 5 square roots of 6, rationalized, of course, equals 12, negative 12 square roots of 6 over 30, which is reducible by a factor of 6, minus 2 square roots of 6 divided by 5. Let me check that. Alright, it's correct. So that's my cosine. So cosecant, sine, cotangent, tangent, secant, cosecant, cosine. Alright, so that one was a little yucky because we had to use the Pythagorean IDs, but it is doable. So I wanted to go over that one with you. Oh, I forgot to hit the timer. I think I'm just going to pause that, and it might have been 10 minutes just to do that one problem. So let me pause that and start part 2.